Hello friends, how are you? I hope everyone is doing great. In the last video, I discussed the fundamental of the functional programming, including key concepts, advantages and disadvantages. Today, I am excited to delve deeper into the topic by focusing on functional interfaces. So first of all, I would like to discuss about what is the functional interfaces and what are the key concepts of the functional interfaces and what are the types are available, how to implement these functional interfaces, okay, how it is different from abstract methods versus like after Java 8. So how different from abstract methods after Java 8, right? And so how to create the custom functional interfaces, how to solve the diamond problem. So this is the topic I'm to discuss in this video. So let's get started. So first of all, like what is functional interface? Functional interface is an interface that contains only one abstract method. So these interfaces also known as a single abstract method interfaces, that is SAM interfaces. So functional interfaces play a vital role in Java 8 functional programming features, enabling the use of Lambda expressions basically, method references and functional style programming construct as I discussed in the previous video. And so where to use these functional interfaces basically? So by using Lambda expressions. So we can use the Lambda expressions to implement the functional interfaces. So how that Lambda expression will look like is which will contains like parameters and expression, right? Yeah, here the list of parameters and we have an arrow mark and the expressions. So the body of Lambda expression can be expression or a set of statements. So they must be enclosed within the curly braces here, right? So the return type and the possible list of expectations that can be thrown are not explicitly mentioned in the Lambda. And yeah, so let's implement one example here. So here I have a preferred customer interface which is containing only one calculate discount method. So which is having one parameter that is amount. And I have one customer class and let's implement inside. Okay, let's implement our method. So that is calculate discount and I'm going to provide the 10% discount to this original amount here, right? So this is my main method and so let's take main method and create the object for this customer, right? So let's call customer dot calculate discount. So let's provide some 100 rupees amount, that is Indian currency, right? So this is basically is going to provide the discount, right? So let's print discount here. If you execute this, you will get the discount, right? This is one way of by implementing in your implementation class. And the another one is anonymous inner class. So have you heard about anonymous inner class? What is the anonymous inner class? So basically anonymous inner classes in Java are way to declare and instantiate a class at the same time, so without providing a name for the class, right? So I'm going to make use the preferred customer here. Okay, new preferred customer, and this is the anonymous inner class. Here I'm going to provide the 5% discount to differentiate between the above one and this one. That's it. So the same thing, copy this and come back and take, yeah, right? So if you can execute, you will get it the 5% discount amount and it will calculate and it will print the discount amount here by using this anonymous inner class, right? 5 rupees. Now, so these anonymous inner classes are defined here, right? So defined and instantiated within the single statement and are often used for like one time or like ad hoc implementations of the interfaces or like subclasses, but here we are using interfaces, right? So this is how the anonymous inner class will be look like. Now Now my goal is, so I need to replace this anonymous inner classes with the lambda expression and this normal class implementation as well. So in the two places I'm going to implement the lambda expressions. Okay, and here the customer is calling the calculate discount, right? So instead of calling directly here, what I'm going to do is I'm going to provide one method. So that method will accept this customer and it will make the logic this calculate discount, right? So like this, I will have one static method which will take our interface and which will call calculate discount. I'm just passing 100 Indian rupees here, right? So what I'm going to do is I'm going to call this. So you got the same output, right? So what it is doing basically, this calculate the discount is accepting your interface and which is internally calling our customer, this customer logic. So I'm going to make use the same method here to implement the function interface, right? So I'm going to replace this method here. So in the place of customer, I'm going to replace this method, right? So now the lambda expression doesn't contain any name. So let's remove this, and coming to this type we already have in our interface, right? So duplication of the code, so let's remove that, and public, so this one also is not required. And coming to this, here also we have already type, so we can inferior that type as well. And okay, let's divide by using arrow token, right? So now it looks okay, right? So but coming to the return type, right? So the return type not required here. And if you are having like single statement, then this curly braces also is not required, right? So let's remove this and let's move to up. That's it. Now here also we have a single parameter. For the single parameter we don't require any. Okay, that's it. And so this is one thing, right? So now coming to like here we have anonymous inner class, right? So this anonymous inner class, if you can observe this anonymous inner class, so this is also duplicating the code, right? So and from here I'm going to remove this part, and so whatever that part we have removed from the above code, right, the same code, right? So let's remove this part as well, and now let's put it our arrow token, and let's remove this one as well, and it's ready. The same thing, return statement is not required here, and this one also is not required, right? That's it. Now let's make it clear. So let's run this, right? So the same output we got it here, right? 10 and 5%. So this is how the lambda expression will work. So basically the lambda expressions to implement the functional interfaces, right? So this is our functional interface. We have a calculate discount method and we are implementing this method by using the lambda expression like this, right? And coming to your functional interface, here we have only single abstract method, right? So suppose you have like one more abstract method, right? What will happen? Let's see. And it is throwing some error, but it's not related to functional interface. So because in your implementation class it is asking to implement that method, but so the problem here is the functional interface will contain like only one method, right? So how would the compiler will know? So to know this, basically you can declare the functional interface like this, so that like you will get the error here itself. What it is saying is multiple non-overriding abstract methods found in the interface preferred customer, right? So it is not allowed if you put functional interface like this, right? So apart from this abstract method, so does it allow any other methods? Yes. Yeah, let me explain that one as well. So now suppose, as I discussed earlier, okay, let's remove this for the time being, and let's copy again that method here, right? So go back to your customer class. So what it is saying, it is asked to implement that method. Suppose you have like 100 implementation classes. If you change something, your existing method, or like if you are added like new method, so the implementation classes will force you to implement that method. So basically you have an impact on your implementation classes. So that, so what you can do is, instead of impacting your implementation classes, I will provide the default method here. So what does it mean? Basically you can provide the implementation here itself. So suppose 0.10 into amount, right? So now if you go back to your implementation class, there is no impact. Even if you have 100 implementation classes, you don't have any impact if you introduce a default method, right? So that is the advantage of default method. And coming to static methods, right? So suppose I have a customer util class here. So this customer util class having the static method. So basically here we are getting the get product type based on this quantity, okay? And now go back to your main class. You can directly call this customer util dot get product type, right? So unnecessarily creating like one customer util class. So what we can do is, we can go for our functional interface. So here we can directly make use this, okay, method, static method here. Let's remove this, and that is the beauty of functional interface. So you can define the default methods as well as static methods. So what is the advantage of static methods? Basically you can get rid of this util classes. You can directly define the static methods inside these functional interfaces. So how to call that functional interfaces static methods? So come back to your main method. With the help of this, you can directly call these static methods. You can just provide like 100 here, and this is string, right? So let's provide product type. Let's print product type. So let's execute this, right? So we got the regular output. So this is how the static method will work. And coming back to your interface, okay, so we have calculate discount amount, and we have single abstract methods, we have a single default and single static methods. And apart from these three methods, does it allow any other methods? Yes, still. So what is that method? So we can go for like object class methods, okay. Let's go to this, yeah. So I just open this object class package. So here you can see equals method and hash code methods, right? So I'm going to copy this hash code method and come back to your interface, functional interface. You can just define this, right? Even if you define the hash code method, it does not throw any error. So let's, even if you declare a functional interface here, it does not warn me, right? So come back to your object package, let's copy this equals method as well, and come here and just paste it, right? So like this you can override object class methods as well. So like this you can create the functional interfaces with one single abstract method with n number of default methods and n number of static methods and object class methods, right? So I said like n number of default methods and n number of static methods, right? So let's put it again, one more default method and one more static method, right? So it's a valid functional interface. So this is how you can create the functional interfaces, okay, and you can implement your functional interface by using the Lambda expression. So till now we have seen like how to implement the functional interfaces by using Lambda expression, right? So now so let me explain so how the functional interfaces methods will look like. Till now we have seen like single abstract methods and multiple default methods and multiple static methods, and which will have like object class methods as well, right? So this is how the functional interface will look like. And now I'm going to discuss about built-in functional interfaces. So there were like functional interfaces which is already exist before Java 8 as well. So it is not like that they are like they are the whole new concept introducing only in Java 8. Okay, so there are like functional interfaces exist before Java 8. So that is like runnable, and we have a callable, and we have a comparable and comparator, and we have an action listener, right? So these are like some old functional interfaces which are already exist even before Java 8. So let me provide some example regarding this. So let's take one main method here. Okay, so runnable basically, let's take runnable. So I'm going to take one SOP here. So as we discussed earlier, this is the anonymous inner class, right? So this is the repeated code, so we can remove directly. So I like this. Okay, so if you are a beginner, so it's a good idea to like first of all like come first of all you can make use like anonymous inner class and you can convert into Lambda expressions, right? So till now you will get like hands-on experience. So yeah, so now let's remove this one as well, because this is the single line, right? Yeah, that's it. And coming to like comparable, or otherwise I will take comparator. So the comparator will take one type. So I'm going to take the customer as a type here, and let's take again, so which will have only compare method, right? So our customer object having like phone number, I'm going to sorting out by using phone number here. So how we are going to do it, let's take o1 dot get phone number minus our object 2, right? Object 2 dot get phone number, right? And here also I'm going to taking the anonymous class, right? So let's remove this repeated code, and here also type is not required, so let's remove this in the both places for the both parameters, right? So let's put arrow token here and remove this return, and let's remove this curly braces again, right? Yeah, so this is how it will look like. So this is also not required. Let's format. So we have a runnable and comparator, right? And so let me add some logic. So I'm just running the runnable run method to print this SOP, right? Another one we have like comparator. So based on this phone number I'm going to sorting out, right, our customer objects. So here I have two customer objects, one is like 1 comma 2. So these are the phone numbers. So first of all, like without this comparator I'm going to run this program. So let's execute this first. Yeah, so we got running run method, and we have two customer objects are printed here, right? So 1 comma 2. So first of all it's printed 4 5 6 and 1 2 3, right? So now let's take collections method, so which will have like sort method. So let's pass list here, and our comparator we need to pass here, that's it. So once you pass this, let's execute this again. So now you will see the output based on this phone number sorting, right? So this is ascending order now. So earlier like we have like without sorting order we we have seen like this printed like without sorting order, right? So now it's printed by using this phone number sorting order, right? So this is how this before Java 8 these are the functional interfaces are already exist. So if any interviewer asked, so we can just explain this. So I'm not going to explain like regarding like action listener and callable. Okay, so those are like same way we can implement, right? Okay, so till now we have seen like how this built-in functional interfaces will work, and now so I'm going to discuss about so what are the types of functional interfaces has been introduced in Java 8, and I'm going to explain the examples one by one. So first of all, like what are the types are introduced in Java 8? So the first one is function, and the second one is predicate and consumer and supplier and a by function and by predicate and by consumer. So apart from this unary operator and binary operator, so I'm going to cover that one as well, but I haven't mentioned here, right? So first of all, like let's see one by one how this will works. So let's go back to the code, and so I'm going to make use the earlier one, that is like our customer class. Okay, here I have added like some other methods like update contact info, get order history. Okay, and these methods are already added like get phone number, like this. Okay, so I'm going to make use this method. So earlier like it was implementing only preferred customer, so now we have two more functional interfaces. So that is like preferred customer 1 and preferred customer 2. So now we have two methods, one is like update contact info, another one is like get order history, right? So these two functional interfaces already implemented in this customer class. I'm going to make use this customer class for this functional interfaces, right? And so first of all, like I'm going to explain about so let's functional interface, right? So what is the functional interface? Basically, if you open this, you will see this functional interface, right? And basically this a function is basically takes an argument of one type and produce a result, right? This will take one type and produce the result. And so let's create one function. So before that, so which is already available in java.util function, right? So what you can do is go to like this java.util function package, and you can see all the functions, sorry, like all the functional interfaces which is already available in Java 8, right? So we have by consumer, by function, we have a consumer, and supplier, we have predicate, right? So all those functional interfaces are available here. And suppose if you want to see the functional interface, here is available, right? So let's click on this, you will get like the whole information, right? So what are the types of parameters are there? Okay, and the type of the input to the function, it is the type of the result of the function, it's clearly mentioned here, right? And so what is the methods are available, so which will have like apply and then compose identity, these are the methods are available inside this functional interface. Okay, let's go back to our code. And so now what I'm going to do is I'm going to create one calculate discount method by using this functional interface. So basically which will take one input type and which will return one output. So I'm going to take two types, one is like input, another one is output. So let's create a discount calculator here, and calculate, yeah, let's miss it here. So now basically I'm going to take amount, some amount, right? That amount, uh, so I'm going to check some if condition inside this. So customer will have is preferred customer. If it is a preferred customer, so I'm going to return some logic here. So suppose we have already amount, right? So I'm going to provide some discount if it is preferred customer, like I'm going to provide some 10% discount. Okay, so if not, so I'm going to provide uh, only 5% for the regular customers, right? So that's what I've written here. What happened? Control. Yeah. Okay. So this is my discount calculator by using function, right? So this function basically having apply method. So suppose uh, in the main method, what you have to do is you have to create object for this, and you can call the apply method by using this discount calculator. So I will show you later so how we can call that apply method, how to pass that okay amount here. Now, so the another one is I'm going to explain about supply, right? So let's remove this supply. Let's open the supplier. So this is the supplier functional interface. So basically a supplier represents the supplier of result and does not accept any arguments here. Okay, so basically it will result it will return the result. Okay, and it does not accept any parameter here. And go back to your class, and here I'm going to take the customer. What I'm going to do is I'm going to creating a new customer instance by using this supplier. Okay, so customer supplier, and um, yeah, basically this is a functional interface, right? So either we can write new customer. Okay, so this customer is a we have like some constructor here. So let's provide id, okay, some name and some phone number, right? So our supplier functional interface also is ready. Okay, and the next one is consumer. So let's take the consumer. Let's open this consumer as well here. So this consumer also is a functional interface. Basically, a consumer is represents an operation that accepts a single input argument and returns no result. Okay, this is accepting the input parameter, but it doesn't return any result. Okay, and now go back to our code. So what I'm going to do is so let's take our customer class here. So I will go so what I'm going to do is I'm going to update my contact info here. So contact info update. Okay, so yeah, this is a lambda expression again. I think for the single argument does not require any braces here. So now already I have update contact info method. So here I'm going to pass this customer dot get name. Okay, customer dot get phone number. So yeah, so these two things I'm going to update, either it could be name or phone number, right? And so here also it's not required this curly braces. Okay, let's okay, so our consumer also is ready now. Now the last one is predicate. Okay, let's open this predicate function interface. Okay, so a predicate also is a functional interface that represents a predicate. So what does it mean basically? So basically it will having like one argument, and it returns boolean. Okay, and now let's go back to our class. So what I'm going to do is I'm going to create like a predicate to check if the customer is a preferred customer or not. Okay, uh, let's provide customer class here. Okay, so preferred so customer dot um, what I'm going to do is customer already have get orders history. Okay, so this customer already having like order history, right? So I'm going to checking that size. So if that size is greater than or equal to 10, okay, so what I'm saying is if it is greater than or equal to 10, then I'm going to say so this is the preferred customer. Yeah, it is. So this is not required basically. Yeah. Okay. Okay. So now till now we have seen like function, supplier, consumer, and predicate, right? So now let's invoke our functional interfaces methods to print out the output. So let's take main method here, and this is a double, that's fine. Predicate types dot, yeah, this is a preferred customer dot test. This is okay, I will discuss later regarding this. Okay, fine. So what I'm trying to do is I just created this object for this functional interfaces. Okay, I just created an object, customer object, and I'm invoking this update contact info here, right? So this one, and apart from this I'm just adding some data to this customer by using this add order history, right? So one and two orders and some data, and after that uh, here, so I'm just calling the discount calculator, so that is function method, right? So this function will contain the apply, right? So I already explained about this. So this is the function apply method, so we need to invoke and we need to pass our amount here, right? So that it will calculate the discount and it will provide. And coming to the supplier, so the customer supplier having like some data, so so it will provide some data here because it is having get method. Okay, this is written the result, and uh, so here we have like uh, contact info updater. This is the example for the consumer, right? So this consumer will have a accept method, so this will accept our customer and we are updating the info here. So uh, here we are updating the phone number, right? So I'm just printing like after that, after updating this info, so how the customer will look like. And last one is predicate. So this predicate will have the test method, so I'm just passing the customer object to test like this preferred customer or not. So I just having some logic. So if this logic is meets, then we can say this is a preferred customer, otherwise this is not a preferred customer, right? So that's it. So let's test this. Okay, so first like function. So the function logic is we are checking whether this customer is preferred customer or not, right? So because this preferred customer, we set it as a preferred customer as true here, right? So if it is preferred customer, then what will happen? This will give the 10% discount. And the next one is supplier. So the supplier is creating the customer object, right? So this is how the customer object will look like. And the next one is consumer, right? The consumer, with the help of the consumer, we are updating the contact info here. So the contact info we are updating, right? So here we have the contact info 144. So after you updating, right, so the contact info has been changed to 456, right? So this is how the consumer will work. And coming to predicate, we are checking like whether it is a preferred customer or not with the help of the order history. If it is meeting this criteria, so if it is a preferred customer, otherwise it's not a preferred customer. So it is a false, that means this is not a preferred customer here, right? So this is just for example, I just taken this predicate. Okay. And go back to our PPT. So here we have mentioned like by function, by predicate, and by consumer, right? So what is by function basically? So let's go back to our object class. So go back to like our documentation. Okay, go back here, and here by function. So by function represents a function that accepts two arguments and produce a result. So earlier, like a function will accept only one input and return the result, right? So now go back to your code. Here basically it is accepting only one input and returning output. So if you are taking like by function, basically let's convert into by function. Okay, it will accept two arguments. So I'm going to take one more boolean, sorry, boolean, right? Let's import this by function as well. And instead of passing one argument, I'm going to pass this is preferred customer as well here, right? So let's take braces, because now we have two arguments. And come back here. So instead of accessing from customer, you can directly take this preferred customer. That's it. So this is the example for like by function. So now this by function will take two arguments and return one result, right? And another one is like by predicate. So the by predicate also is the same thing. So by predicate, predicate will take one input, right? So go back to our, yeah, so by predicate, yeah, so by predicate also like same thing. So it represents a predicate, okay, uh, of two arguments. Okay, so basically which will accept two arguments and return the boolean result. And coming back to like consumer, by consumer, so here also the consumer is taking like one argument. So by consumer also will take two arguments. So suppose let's take by consumer. Okay, instead of customer, what I will do is I will take string comma string. Otherwise I will take a string comma int, right? So I will take like name and phone number. I will update the logic based on this by consumer logic, right? So like this you can make use this by consumer as well. Okay, uh, let's go back to our original code. Yeah, I think okay. And so like this we don't have any by supply. Okay, that is the reason I haven't mentioned here. And coming back to like our code, one more thing, we have a binary operator, and sorry, we have a unary operator and binary operator. So what is a unary operator? Basically unary operator is same as function. Okay, let's go back to Yeah. So basically it represents an operation on a single operand and that produce the result of the same type as its operand. So basically this unary operator is same as function. So what the function will does is basically it will take one input and return the output, right? So but the something is different, same as function, but argument and result should be same types. Okay, so suppose if you are passing input as integer, the output also integer, then so in this case you can go for unary operator. Okay, so let's show you something example here. Okay, um, so this is the unary operator example. So what I'm doing is I'm just taking the customer as object type here, and I'm just setting the phone number here, and I'm returning the same type, that is customer, right? And coming to like binary operator, what is the binary operator? Basically it's same as by function. Okay, so same as by function, but argument and result should be same here. So binary operator will take like double and um, double as type here. So amount 1 and amount 2 is double types, so I'm going to calculate this amount. I'm just returning this amount here, right? So in this case input and output both are double, so that is the binary operator. So let's execute this. Okay, and let me show you that output as well. Okay, so we got so this is the, let me come back here. So I'm just calling this types comma unary operator. So this unary operator as well having like apply function, okay, apply method, so which will accept the customer, and I'm just printed like updated customer phone number. Okay, this one. And coming back to like this binary operator will also have the apply method which will accept the same type of input, that is like double type input, and return the double type amount, right? So I just added like 100 plus 200, it is written 300, right? Perfect. So this is how the functional interfaces types will be work. Okay, so the next one is primitive function specialization. Okay, so basically we have a functional interface, right? To support primitive types we have like some of the functional interfaces. Those are like int function, a long function, double function, and we have a two int function, two long function, and two double function, and we have double to int function, double to long function, as well as we have a int to double function, int to long function, and long to int function, and long to double function, right? So now I'm going to explain that examples here. Okay, so here I just taken this int function. So basically what is int function? It represents a function that accept an integer, okay, integer argument, and produce a response, produce a result. Okay, so if you open this int function you will see the functional interfaces, and which will accept the integer value and which will return the response, right? And so that's what I'm doing here. I just passed 10 here. Okay, and we got the same output, right? And the next one is toInt function. What is a toInt function? Basically it represents a function that accept an object, okay, and produce an integer result. So I'm just passing the string as 42 here, and it will convert into integer, and it will produce the output as a 42 as an integer. Okay, and that is the example for like toInt function. Coming to like int predicate. So what is the int predicate? Basically int predicate is nothing but it represents a predicate, okay, and that is like boolean value function. So I'm just checking whether it's a even number or not, that accept the integer value, okay, and returns the boolean, okay, boolean uh, boolean value. So basically it will accept the integer value and returns the boolean value. So that is, I'm just passing 7 here, and it is going to say whether it's a even number or not. That is the logic I just wrote here. And coming to like int consumer, so what is the int consumer? Basically it represents an operation that accepts a single integer value, okay, and basically it returns no result. So I'm just passing the 5 here, and internally it will calculate square number into number, and it is going to output as 25. That is example for like int consumer. Coming to like int supplier, so basically int supplier is basically represents a supplier of integer results. It doesn't take any argument, and but it will return the output here, right? So I'm just using this math random value, okay. So I'm going to print this math random number here. That's it, right? Let's execute this and see this primitive function examples, right? So first we got 10, and after that we got 42, and is even, it's not a even number, that's why we got false, and square is 25, okay, and we got random number as 39, right? So this is how we can make use this to support like primitive types, okay. Okay, so now I'm going to discuss about composing functions. So first of all, like I would like to discuss about what is composing functions. A composing function is nothing but function composing involves like combining multiple functions to create new function. So we can achieve by using the below methods. The first one is like and then method, and by using compose method. Okay, let's see practically. Yeah, so here I just taken two functions, right? So the first function double function, and the second function is add 3 function. So the double function is doing like multiplication, add 3 function is doing addition here, right? So the first one is I'm doing combine function, right? This combine function, so I'm invoking the double function first, and I'm invoking and then function, okay. So this and then function, if you want to see the more details, you can go to this functional interface, you can see all the details, okay. And I'm just invoking add 3 function here. So what will happen is, first of all, like uh, it will execute this double function, and then it will execute add 3 function, right? So if I call apply method on this combine function, then I will get like 5 into 2, okay. The first is double function, so that is 10 plus add 3 function, right? That is 10 plus 3 equal to 13. And come back to like compose function. So here I'm, first of all, I'm calling double function, and I'm calling compose method on top of this double function, and I'm invoking add 3 function. So the compose is reverse to this and then function. So first of all, like the compose function will call add 3 function, okay, that is 5 plus 3 8. Again it will call the double function, that is 8 into 2 16, right? So that's how it will work. So let me execute this. Okay, so and then function is 13 and compose function is 16, right? So it's working fine. Yeah, so now I'm going to discuss about functional interface extending non-functional interface. So here like there are like three scenarios. One is like, can we extend non-functional interface inside functional interface? Okay, that is the first one. And the second one is, can we extend functional interface in non-functional interface, right? This is the reverse case. And the third one is, can we extend functional interface inside another functional interface? Okay, so these three scenarios I'm going to discuss. So let's go back to our code. Okay, yeah, here I already have, let's maximize this. So a adder is a functional interface which is contain only one abstract method, that is add, right? So suppose I have a one more interface, this is non-functional interface, because I have two abstract methods, right? So if I extend this non-functional interface inside this functional interface, what will happen, right? So the compiler is thrown error. So what is saying that multiple non-overriding abstract methods found in interface adder, because this is the parent interface. We are extending the smarter adder, right? So these two methods will inherited into this adder, so that like we will get like three abstract methods, right? That is the reason it is throwing this error. So we can't extend non-functional interface inside this functional interface. So in the reverse case, can we extend this functional interface in non-functional interface? Yeah, of course, because so non-functional interface can have multiple abstract methods, right? That is the reason we can extend this functional interface inside this non-functional interface, right? And there is no error. So now, yeah, suppose I'm going to remove this. Now this smarter, so this smart adder also having only one abstract method. Suppose let's assume that this is also functional interface. Okay, if I extend this inside my functional interface, that is, now both are like functional interface. Can we extend that? No, because this is one uh, method. This method signature is different from this method signature, right? So then it is start throwing the error, multiple non-overriding abstract methods is found. Okay, so what if I have the same method signature and same return type, then it will allow. Okay, there are no errors, right? So this is how you can extend like functional interface inside the non-functional interface. So now I'm going to discuss about, can we create custom functional interfaces. Okay, so most of the interviews asking this question, so that is the reason I'm prepared this one. So suppose like if anybody asks regarding this custom functional interfaces, so you can create it. So let's open my IDE. So here I have written one custom function. So basically we already discussed about function, right? So the function will take one input and return another output, right? So same thing, so you can apply for the custom function as well. So I just taking one input and another output. So I just wrote one apply method and I declared the functional interface. So even if you are not declared, there is no problem, because for this safety purpose I just added the functional interface. And now go back to our main class. uh, yeah, here also like I just extended this custom function. Okay, so I'm just passing integer and integer here. So the apply method will take input and it will return the output, right? So coming to the lambda expression, same thing. The lambda expression is having this arrow token. So I'm just checking whether this less than 0, I'm just throwing the exception. Okay, if not, I'm just applying the value and I'm just executing that value, right? So the another one is, can we handle the exceptions in functional interfaces? Yes. So you can create one custom exception, so that is extends the exception. So I just created one constructor and passing the message to that constructor, right? So here what I'm doing is, in the lambda expression, inside this lambda expression I'm just uh, handling the exception with the help of the try and catch. So if the value is less than 0, I'm just throwing this newly created custom exception. I'm just providing some input message here. The input is negative, and okay, and inside this catch block I'm just printing the exception stack trace, and I'm returning -1. So here I'm just passing like two results. One is positive number, another one is negative number, right? So I'm just printing this. So let's execute this and let's see the output, right? The first one is result 1 is 10 and result 2 is -1, because the second one is negative number we have passed, right? That is the reason it is returning negative number -1. And we have exception card, right? So the same thing, exception card input is negative. So this is how you can handle the exceptions inside these functional interfaces. So now I'm going to discuss about the diamond problem with the functional interfaces. So how to resolve this diamond problem with functional interfaces. Let's go back to our code. Okay, so here I have like customer class and customer one class. Two classes are there, right? So here I have a prefect uh, preferred customer variable, and we have a abstract method get address, and we have a calculate discount is a default method, right? So each functional interface we have a two methods, one is like get address, another one is calculate discount. The same methods is available in the customer one as well. So if you implement this in one class, that is diamond problem class, so it will ask to implement both the methods, right? So let's implement both methods. Okay, so coming to like abstract method, so in the abstract method, okay, so we have to provide implementation in the implementation class, right? So suppose my address is Hyderabad, so then I will provide the implementation. And coming to this calculate discount, right? So the calculate discount is a default method. So either you can call, so either you can provide the implementation of like customer interface or like customer one interface. So with the help of customer, we have a super keyword, we can call the calculate discount method. Okay, so this is how you can call by using this super keyword. So the customer and customer one, so if you want to invoke the customer one calculate discount, you can just provide here. Otherwise, if you want to provide like your own implementation, then you can just provide your own implementation as well, right? So suppose you want to provide the 10% discount, okay, so you can provide the 10% discount like this, right? So this is how you can uh, provide the implementation for the default implementation classes, right? Suppose let's execute this. Okay, we got uh, 0 0.1, so that means 10% discount. So the same thing you can call for address as well. Okay, okay, we got the Hyderabad. So like this you can solve this diamond problem. Okay, so the last one I'm going to discuss about what is the difference between abstract class versus the interface after Java 8. Okay, some changes are made in the Java 8, right? So those are the difference I'm going to explain here. So first of all, like multiple inheritance. Okay, so multiple inheritance, coming to like abstract classes, so cannot extend multiple abstract classes here. And coming to interface can implement multiple interfaces here. And coming to the constructors, here coming to the abstract class can have constructors, whereas interface cannot have the constructors, right? And coming to the fields, can abstract class can have instance variables, right? And whereas like interface cannot have the instance variables, right? And coming to this methods, methods basically coming to like abstract class, so abstract class can have both abstract and concrete methods, right? The interface can have only method signature. So pre-Java, that is Java 8, and method implementations available after Java 8 as well. So using default and static methods, right? And coming to variables, so abstract class can have final, non-final, static, and non-static variables. Okay, whereas interfaces, all variables are implicitly public, static, and final. Okay, and coming to usage in the lambdas. So if you come back to like abstract classes, so abstract classes um, cannot be directly used the lambdas, right? So whereas coming to interface, we can use in lambdas as they can have functional interfaces. So that is like single abstract method interfaces, right? The next one is extension by interface. So abstract classes cannot provide the implementation through the interfaces, right? So whereas come back to like interfaces, interfaces can provide the default implementation for methods through the default methods in interfaces, like through Java 8 onwards. And the next one is, yeah, so come back to like abstract classes again. So here we have an extension by abstract class, right? So here abstract class can extend the another abstract class. So whereas interface cannot extend the multiple abstract classes, right? And here inheritance like abstract classes can support say single inheritance hierarchy. Okay, and whereas interfaces supports multiple inheritance through the interfaces, right, as we discussed previously. And coming back to like default methods, so default methods, abstract classes does not support static methods, sorry, default methods, whereas interfaces supports the default methods, right? So same thing is applicable for static method as well. Abstract classes does not support the static methods, whereas interfaces can support the static methods. And the last one, uses in the streams. So usage in the streams, abstract classes can define, so we can define and use in stream operations, right? So whereas coming to interfaces cannot define directly these abstract methods because stream operation, because without creating the concrete class, without creating a concrete class implementation for these interfaces, we can't directly make use this interface methods in the streams. Okay, so these are the differences. Okay, are there okay, so this is the difference between abstract class versus interfaces after Java 8. Okay, yeah, I think I done like I covered like all the concepts for this functional interfaces. If I miss anything, so please let me know in the comment section. Okay, so thanks for watching. So please like and subscribe my YouTube channel. Thanks for watching. Bye, have a good day.